Operating System OS B7. What is RAID? So RAID is redundant array of independent disks. RAID is a technology that allows multiple physical hard drives to work together as a single logical unit in order to improve data storage performances, reliability, and fault tolerance. RAID works by storing data across multiple hard drives rather than on a single drive. This means that if one drive fails, the data can still be accessed from the remaining drives in the array, which improves the overall reliability of the system. RAID can also improve performance by spreading data across multiple drives, which allows for faster read and write times. RAID, there are several different RAID configurations, each with its own advantage and disadvantages. This includes RAID 0, 1, 5, 6, and 10, and many more. Each of these RAID configuration has a different combination of data stripping, data mirroring, and parity information that provides different levels of performance and fault tolerance. So RAID 0, 1, and 3, and RAID 5 are all different types of RAID configurations that offer different levels of performance and fault tolerance. So let's start with RAID 0. This is a configuration that uses data stripping to spread data across multiple hard drives for improved performance. RAID 0 does not offer any fault tolerance, as there is no redundancy in the data. This means that if one drive fails, all data in the array is lost. So, this is the key features for RAID 0. Requirements: a minimum of 2 disks, no redundancy, data is stripped across disks for improved performances. So, installation involves selecting the RAID 0 configuration in the BIOS or the RAID controller setup utility. Choose the disk to include in the array and configure them as RAID 0. So, initialize the RAID array and format it for use by the operating system. So, next is the RAID 1. RAID 1, this is the configuration that uses the data mirroring to create a redundant copy of the data across 2 or more hard drives. In this configuration, each drives contain the same data, which provide fault tolerance. If one drive fails, the data can still be accessed from the remaining drives in the array. So, also, the RAID 1 is also known as mirroring. So, requires a minimum of 2 disks like RAID 0 and provides redundancy by mirroring data between disks for fault tolerance. So, installation involves selecting the RAID 1 configuration in the BIOS or RAID controller setup utility. Choose the disk to include the mirror set and configure them as RAID 1. So, initialize the RAID array and format it for use by the operating system. Next is RAID 3. This is a configuration that uses byte-level data stripping and dedicated parity drive to provide fault tolerance. In this configuration, the data is stripped across multiple hard drives, and dedicated parity drive is used to store the parity information. If one drive fails, the data can be reconstructed from the parity information and the remaining drives in the array. So, in RAID 3, requires a minimum of 3 disks. So, RAID 3 uses byte-level stripping with a dedicated parity disk for redundancy. Installation involves selecting the RAID 3 configuration in the BIOS or RAID controller setup utility. Choose the disk to include in the array and configure them as RAID 3. So, initialize the RAID array and format it for use by the operating system. So, last will be RAID 5. This configuration that uses block-level data stripping and distributed parity to provide fault tolerance. In this configuration, the data is stripped across hard drives and parity information is distributed across all drives in the array. If one drive fails, the data can be reconstructed from the parity information and the remaining drives in the array. RAID 5 offers a good balance between performance and tolerance. RAID 5 requires a minimum of 3 disks like the RAID 3. It uses block level stripping with distributed parity across all disks for fault tolerance. Installation involves selecting the RAID 5 configuration in the BIOS or the RAID controller setup utility. Choose the disk to include in the array and configure them as RAID 5. Initialize the RAID array and format it for use by the operating system. So what will happen to the file and drive? When you insert a text file on each RAID drive and then destroy one disk of different technology, the RAID array, typically configured as RAID 1 for mirrored redundancy, ensures that the data is duplicated across multiple drives. Even if one disk failed due to damage or other issue, the RAID array maintains its functionality. In this scenario, the text file should still be accessible from the remaining drive, as it contains a complete copy of the data. However, until the failed disk is replaced with one matching the technology of the other disk, the RAID array operates with reduced redundancy. It's essential to replace the failed disk promptly to restore full redundancy and ensure the integrity and reliability of the RAID array. So what will happen installing the new addition or disk? When a new disk is inserted into an existing RAID array, it undergoes detection, initialization, and potentially reconstruction or redistribution of data to maintain redundancy and performance. Capacity expansion may occur if supported, optimizing performance and reliability. Finally, the data verification ensures integrity across all disks, ensuring the RAID array remains resilient and efficient with the new addition.